Hi, I'm an old guy and I do maths, and today we're trying to find the shaded region of this odd looking shape. Um, now, um, there's a better image of this if you find this confusing. This is the shading. There's a better image of this at the start of this video, so if you want to stare at it, pop back there and just freeze the picture and you can see everything set out really clearly. Now, what we have is we have something that looks like a piece of fruit lying on its side, a pear or something like that, and it's got two holes taken out of it. Now, the key to figuring out what the area of something like this is first of all to recognize the shapes that make it up. Now, I've done a rough artist's impression of the shapes that make this up, minus the holes. Don't worry about those for the moment. We've got a semicircle over here. We've got a trapezium in here, and we've got another semicircle. Okay, now the second thing to realize is that once you've figured out the shapes that make up the basic composite, and you work out the area that they occupy, if you want to know what the area of the shaded region is, you take the area of this and this away from the whole. Now, so the first thing we're going to do is we're going to work out the area of this. Now, to do that, I'll just take a blank piece of paper and go to work. So the first thing is to take a look at the shapes that we've got. So we've got a semicircle, that is 40, so the radius is 20. This is 20, so the radius is 10. And this is the trapezium. Now, this is the length here, 20. This is obviously not to scale. And this, 40, is the length here. And if you look back, I'll just bring this back into the picture. This distance here is 50, so the height of this trapezium is 50. So we're going to assume that pi in this case is equal to 3.14. We're not going to get too fancy about this. Rightio, so we're going to work out the area of this semicircle. The formula we need is pi r squared over 2 for a semicircle. So let's go. Pi times 20 squared, 400, equals 400 pi divided by 2, which is 200 pi. We're going to leave it at 200 pi, and we'll multiply up later by 3.14. We'll do the same for this. Pi r squared, r is 10, pi times 10 squared is pi times 100, so it's 100 pi, and this, the area of this is 50 pi centimeters squared. I should write in centimeters squared. Now, the trapezium, the formula for a trapezium is a half a plus b times height. Now, the height of this is 50. We'll call this a, we'll call this b, it doesn't matter which is which. 40 plus 20 is 60, so that's a half of 60, which is 30 times 50, the height. 30 times 50, 3 fives are 15, and we just have to worry about the zeros, is 1,500 centimeters squared. Okay, now we can put all this together and we can get the area of this basic shape. So 250 pi, that's the 200 pi plus the 50 pi here, and we'll call pi 3.14 times 3.14. That equals 785, and to that we are going to add 1,500, and we get 2285 centimeters squared. That's the basic shape. But remember, we have two circles to take out of that. So we have circle 1, which is very badly drawn, but nevertheless it will do. It has a diameter of 10, so a radius of 5. And circle 2 has a diameter of 4, so a radius of 2. So this is going to be pi times r squared. Because it's a whole circle, we don't divide by 2. Radius is 5, so that's going to be 25 times pi. And the radius of this is 2, so 2 squared is 4, so this is going to be 4 pi. Right, so we have in total 29 pi as the area of these two circles. Now 29 times pi, which we are, remember, using 3.14 as our value of pi. Okay, that is 91.06. 91.06. It's not 60, 06. Get that right, 06 centimeters squared. So we have the basic shape, and we have the shapes from which we are going to subtract. Okay, so we're going to subtract 91.06 from 2285 centimeters squared. And we get 2193.94 centimeters squared. That's how we do it. So that minus that. Now let me go back to the original drawing. It is the total area, including these, then minus the area of those two. We break the problem up into its parts and we find the requisite areas, which is what I did up here. That's the total area of these shapes put together, using 3.14 as pi. If you push the pi button on your calculator, you will get a more accurate answer, but we're accurate to within half a centimeter squared, I would say. And as an exercise, this is about showing you how to do it. I think if you use pi on your calculator, it'll be 2,194 point something. So it's very, very close. So we worked these out. We worked out the area of the two circles and we subtracted this area from this area. So that minus that gave us that. And that is how it's done. I hope that this was understandable and that you found that it's possible to find the area of a fairly complex and daunting looking shape without too much trouble. Anyway, if it was useful, please like and subscribe, and I will see you later. Bye.